in a file called fsimage. Fsimage means file system image. Okay. So this fsimage contains your metadata. So file system metadata is stored on name node, and file system metadata contains majorly the file names, file permissions, locations of each block of files. Okay, and so this metadata fsimage file gets stored both on Linux file system, both on LFS and as well as into main memory of the name node. So main memory means it stores that fsimage copy, one copy in RAM memory, and the same will be present in your LFS as well. LFS means your Linux file system. So that is on hard disk. So one is in hard disk and the other one is RAM. So the reason why it stores that copy in RAM is obviously to improve the speed. So anything will be stored in RAM to get the performance benefit. Since there will be only one active instance of your name node, and all your requests will go through that name node, and it has to serve those requests very quickly, it stores that metadata in the RAM memory. That means you should have enough RAM memory for the name node machine. Okay. And name node is a single point of contact for accessing files in Hdfs. And it determines the block IDs and locations for those blocks for a given file by the end user. Right. So in all my slides, I will be referring that only one active instance of name node will be there, and name node is a single point of contact for accessing all those things. But in the terminal, when I have shown you, you have seen the two names there. So I will come to that point maybe in another 4 or 5 slides. Okay. So till then, assume like there will be only one active name node. So the important components inside the name node are, one is fsimage file, second one is the edit log. So fsimage file is the metadata file system metadata file, which contains all these things: file names, file permissions, locations of all those things, including mapping of blocks to files and file system properties. So let's say on your Hadoop cluster, you have 1 million files loaded onto your Hdfs. So all those 1 million file names, their permissions, their owners, groups, and replication factor, and the block IDs, and their block locations. So all that information will be stored in this fsimage file. And this file will be present both in RAM memory as well as your Linux file system LFS. Now, what about the second component? What is the second component importance? Edit log is a transaction log, and it resides in the name node's local file system. Only the local file system, not into RAM memory, and it contains a entry. It contains a entry for every change that happened to your file system metadata. So that means when you started your Hadoop cluster, so when you restarted your Hadoop cluster, so restarting Hadoop cluster means restarting your name node. So just restarting the name node will restart the entire Hadoop cluster. Okay. So when you restart a Hadoop cluster, this FS image file, whatever was there from the previous restart, before the restart, the same FS image file will be carried out. And after successful restart of your cluster, your edit log will be an empty file. Okay. So for now, let's assume I just restarted my name node or Hadoop cluster. So I will have some 100 files in FS image file, and my edit log file will be an empty file. Now, out of those 100 files, I deleted one file. So that delete entry will get captured into this edit log. Okay. And I inserted one new file. I created one new file. So that new file insert transaction will get recorded into this edit log file, but not into FS image file. Okay. So let's assume the restart. So before restart, after restart of name node or Hadoop cluster. So after restart, FS image contains 100 files and your edit log is empty, 0 records. It's not files actually. 100 records about, records about 100 files. Okay, so records for 100 files. So some question. So what is the difference between RAM memory and LFS memory? Okay, good question. So RAM memory and LFS memory. LFS means your hard disk, Linux file system. So anything that you have on your C drive, D drive, so that is local file system to your Windows. Similarly, on your Linux machines, so anything that you present that you can see in your file systems, that is your local file system or Linux file system, I can call. Okay, so that local file system means you have this data in your hard disk, and having something on RAM memory. So you know about what is RAM, right? So having it on RAM means in computer terminology, to process anything, first all your input data might be present in your disk, hard disk. From there, the data will get read into RAM memory, and from RAM memory, that data will get processed. Okay. So keeping anything inside RAM memory means you want a faster performance on that. So directly reading from LFS will be relatively slower than reading anything from your RAM memory. And I hope you know the difference between RAM and hard disk. Okay. So, but this will take a lot of space. I will come to that. Okay. I have its own pros and cons. I will come there and I will explain those things. Okay. No need of hurry. So This is just a metadata, okay, not the actual file you are storing. So this is just the metadata. Suppose you have some 10 GB file. So you have 10 GB file and so blocks. That means 10 GB by 128, number of blocks, 128 MB blocks. So for this entire 10 GB file, so what do you store in your FS image? Just the name and its file permissions, whether it is accessible by the owner or user group or the others. Okay, so permissions related to owner, group, and others, and who is the user, who is the owner, what is the group he belongs to, and what is the replication that this file has, and the block IDs for this file, and where each of these block IDs are located in. So only this much of information for this entire 10 GB file. So for this entire 10 GB file, to store this one record about the metadata about that file will take approximately 4 KB of size. So assuming that there is 1500 blocks created, total 1500 metadata will be there. No. So metadata will not be present. By block level. It will be by file name. So if there is one file, so for that one file there will be one record. Inside that one record only, it maintains all the block IDs and the locations of the blocks. Okay. So there will be only one entry for this entire 10 GB file, and this one record will take approximately 4 KB of size. Okay. So what is the difference between vertical and horizontal clustering? What Hadoop uses and why? All of a sudden, I think we are moving into different context here, Akila. Let me talk that maybe at the end of the session. Okay, so just remind me. Okay. So here, even this 10 GB files, total storage capacity is 10 GB. Now, if this metadata for this file is just going to take around 4 KB, because this is just one record that it is going to store in the FS image file. Okay, so you will understand the reason why I'm explaining that slowly. Now, so I was explaining you the difference and the different purposes of this FS image and edit log. So before restart, I'm not telling you what it had, but after restart, just after restart, so my FS image file is having 100 records, about 100 files, and edit log is empty, 0 records. Now, after restart, you removed one file removed, and 2 files got created. So these 3 records will be inserted into edit log, but not into FS image file directly. This is like in any typical transactional processing systems where we will have one master file and one transaction file. That architecture, that design is followed here. So even after, let's say, even after restart of 2 days, or 3 days, or let's say after 1 week, so you have another 50 files got created. So even then, your FS image file will still have only the 100 files into your FS image, but in your edit log, you will see 50 plus the about 53 records present in this. But in this master and transaction file design, so at certain point of time, you should merge all your transactions. You should copy all your transactions into your FS image file and make that FS image file having all that 153 records, right? So when this will happen is, again, so when you restart, again, whenever you restart your name node, so during that restart, so your name node will take minimum of 30 minutes or half an hour during that time. So that is called as safe mode. So whenever you restart your cluster, your name node will enter into safe mode. So during that mode, you will not be able to create any files. You will not be able to update or delete or any files. Okay. So during that half an hour or 1 hour window, when you are restarting your cluster, so that window period, so it merges all the edit log records with the FS image file, and it creates the updated FS image file with all the 153 records, and it flushes out this edit log. That means it is again an empty file.
Shiva, one question.
Yes.
Will it be 153 or 152 records, because one file is removed?
Okay. Okay. So you're going by this. Okay. Yeah, it will be 152 only.
Okay.
Okay. Sorry.
Hey, Shiva, sorry to interrupt you, Shiva.
Yes, I mean.
I am not able to get the context. I'm sorry. What you are trying to explain? I'm a little bit lost here. What is this edit log, and what are you trying to do?
Okay. So the context here is, so what are the components that will be present in name node? Okay. So if you know the components inside your name node, you will understand the responsibilities of your name node. So responsibilities of name node, I was explaining, it stores the metadata about all the files present on your HDFS. Right? So this till here, did you understand?
Yeah, till here I understood, yes.
Okay. So where does this metadata get stored? In FS image file. Okay. So generally, so this much of depth of information you don't need as a developer, because you will not be given access to FS image file, and you will not be given access to edit log file. You will never be able to see those files. Okay. So the reason why I'm explaining is, at least once you know these terminologies, you will not, when you are going through some textbooks, or when you are reading through some blogs, if you come across these words, you should not feel it like it's something altogether new. Okay. So this is mostly useful by administrators. FS image contains only all the files metadata. Yes. So that just one line is enough for you guys, if as long as you are looking for developers.
And what is edit log, Shiva? I lost you on that one.
So coming there, Anand. So FS image contains the metadata about all the files, and this edit log is like a transactional file. So when you are storing the metadata about all the files, So it stores only the static information, FS image file. Static means when you restart your Hadoop cluster. So before restart, so let's say if it had some 100 records, and after restart, it will be more than that. And after restart, your restarting of your Hadoop cluster, your edit log will always be empty. So this is like a typical master file and transactional file processing mechanism in any enterprise organizations where you have one big master file. We will have the master will have millions of records, and transactional file will have the transactions that happened for that particular day. And that end of day, you will run a batch process which will take this transactional log and will merge these records with the FS image. Still lost or?
No, this is actually very good. But then why do we merge again the edit log? Because the FS image, we already have that.
It's not having, right? See, it's a typical master and transactional log design. So let's say you have, so generally in any enterprise organizations, you will have one big master file. It contains the transactions that happened till yesterday. And today's transactions, whatever you are running, all those transactions will be written into some separate transactional file. And every day in the midnight 12 o'clock, so this transactional file will get merged with the actual master file. And now the actual master file will have the all the transactions till last minute. And your transactional file will become empty.
This is all, Shiva. This mechanism is only to stop flooding of main memory. Correct.
So that is one reason, and the other reason is instead of touching this, since in your pseudo machines, even in there you will see some hundreds and thousands of files if you use it for a couple months, and in content clusters you will definitely have millions of files. Instead of inserting into that 1 million file and deleting one record from that file, so writing those records into this one small file will be faster, right?
Yeah.
So instead of deleting one record from 200 MB Excel sheet, writing that record into one empty Excel sheet will be faster. Just opening the 200 MB Excel sheet on your Windows machine itself takes time, and to delete and save that, it takes relatively longer time. So that's why master and transactional file design comes into picture. So this is typical master transactional log mechanism.
So this is like more like a full load and incremental load. So incremental is
exactly. So this is the load till yesterday. Assume this is the incremental records that we received today.
Shiva, quickly, in our yesterday's example, remember I told you that if it fails at 251 block.
No, I will come to that, Anand. The failure scenarios I will cover. Okay, because I was telling yesterday also. So since you guys asked some questions there, instead of keeping you past there itself, I explained some of them, but I will cover the failure scenarios.
No problem.
Let's not jump into another context. Okay, so that's where, I mean, this one I explained when Neetu asked that question. So it will be of too much storage needed, right? So then in that context, I explained this again. If I go into different contexts, others will not get it. Okay, so here FS image will contain the files till yesterday, the records for all the files that were present till yesterday. And this edit log will contain all the records that were inserted, deleted. Those entries will be present in edit log. Okay. So here, unlike every day, the batch runs in the midnight. So it is not like that. Only when you restart your name node, then only this edit log records will get merged with FSMH file, and this FSMH file will now contain 152 records, and edit log will become flushed. That means it becomes again empty. So for some reasons, or restarting your name node that frequently is not recommended, because restarting name node means you are bringing down your Hadoop cluster. So maybe in your dev environments and QA environments, it might be okay, but in your production environments, if you bring down your Hadoop cluster for 1 hour or 2 hours, so that will be a big impact on the business, right? So to avoid such scenarios, and so in order to avoid that, maybe if you restart your Hadoop cluster once in a week during the Saturdays and Sundays, maybe that time, so by that time your edit log in bigger organizations may run into some millions of records. So this transactional log itself may turn into millions of records. Okay, so in that case, and GBs of storage. So in that case, so if you have millions of records or GBs of storage, this entire edit log file itself, then to restart that during that restart time, as I was telling, this merge happens with master file. So when you have millions of records, it relatively takes longer time. It may take 5-6 hours or 10 hours of downtime or so, maybe. Just giving some figures, okay? So 5-6 hours of downtime, which is again not a good idea. And so to avoid these scenarios, so we have got one more supporting node, which is a secondary name node. So what it will do is, and before even coming to this, so what it happens is, something happened to your name node for prime. Something happened to your primary name node in this scenario. Okay. So during this last 1 week, you have 1 million records and GBs of storage in edit log, and a few records in FSMH file. And all of a sudden, something happened to your primary name node. And you will not be able to recover its FSMH file to start your Hadoop cluster. If you lost FSMH file, that means you will not be able to access your Hadoop cluster. You don't know the list of files itself. Then how can you access the contents of those files? Okay. So to avoid that failure scenarios, your secondary name node comes into picture. So to avoid that failure scenario, and also to reduce these downtimes. So two purposes. So how does it solve those two purposes? Is that for every 1 hour, secondary name node brings the FSMH file that is present in the LFS of your name node. So for every 1 hour, it goes to name node and brings this FSMH file and edit log. Now it has both FSMH and the latest edit log file, and it merges these two files. It merges these two files and updated FSMH file. Updated FSMH file will be copied back to your primary name node, and it maintains one copy. Secondary name node maintains the one copy of the FSMH file, and it sends that copy back to your primary name node, and it flushes out this edit log. for every 1 hour. So that means your edit log will not grow beyond some certain size. So even when you restart your cluster for the next time, at max it might have the transactions that happened during the last 1 hour. So during 1 hour means it might not be that huge. So that in that case, if you restart your name node whenever it is needed, so your restarts will not take more than 10 to 15 minutes. Max of 5 to 10 minutes or 15 minutes. Okay, so that way it reduced the downtime, and all of a sudden now name node gone down. So you fixed some hard disk gone or something, some machine got restarted, and even the hard disk also gone. Disk storage is also gone. Now you have the updated FS image file, which is just an hour, 1 hour back created. So that FS image file you have with your secondary name node, and that can be copied back to your primary name node, and you can restart this name node after fixing the whatever the network issue or the storage issues, disk storage issues. So after fixing those storage issues, you can bring your Hadoop cluster status back to whatever the status it was just an hour back. Am I going too much deeper into these concepts? Generally, what is the frequency of restart and who is responsible for restart? Is what are all the scenarios we will restart or we should restart name node? You don't need to worry about this. Generally, developers will never have access to that, and admins will have access to this, and they are responsible for this. And even they don't restart that frequently. Might be you might see once or twice in a month, only during their upgrades or some kind of patches. Okay, but doesn't the secondary name node take up the task when name node is down? No. So this is one another point that I wanted to highlight. So don't judge by name. Secondary name node will never act like a primary name node. So if your primary name node goes down, your secondary name node will not serve the requests. It is only to reduce the responsibilities or the workload on the primary name node. It takes this FS image file and edit log for every 1 hour, and it merges these two files, and the updated FS image file puts that back to primary name node, and edit log, it makes the edit log becomes empty for every 1 hour. And whenever this primary name node goes down, you have the option to get that updated latest FS image file copied from your secondary name node to primary name node or active name node. So now let's assume, so you have taken backup at 7 p.m. Okay, so you have taken backup at 7 p.m. and so your secondary name node ran this process of merging FS image file with edit log. The process of merging this FS image file with edit log is called as checkpointing. It's called as checkpointing in the Hadoop terminologies, in the cluster terminologies. So let's assume this checkpointing happened at 7 p.m. And so your name node has the latest status that is received, FS image file, let's assume 152 records. And so it was running fine till 7:55 p.m. And now your FS image file has 152 records, and during this 55 minutes, 10 files got created. So during this 55 minutes, 10 files got created. Now, in another 5 minutes, this merging will again happen and your FS image will get reflected to 162. But at this point of time, your name node has gone down. Now, if you restart here and some disk storage issues happen, something happened, and you lost both the FS image file and edit log file. And in that time, if you recover from secondary name node, you will still have 152 records only, and you lost these 10 records. So to solve this purpose, so Hadoop 2.0 architecture, in Hadoop 2.0 architecture, it brings a concept called high availability. High availability by maintaining the backup name node. So till now, you are assuming by secondary name node, it's by looking at its name, you are assuming like it might act like a backup, but that is not the backup name node. We have a separate backup name node concept. Backup name node. So in what will happen in this backup name node? So for every 1 hour, so now you have one primary name node and one backup name node and one secondary name node in Hadoop 2.0 architecture. So these two will be always in sync. Primary name node and backup name node will always be in similar status at any point of time. So how it achieves is FS image file copy will be present, same copy will be present both in the primary name node and backup name node. And for every 1 hour, it gets the FS image file and the edit log from the, but this edit log will not be present neither in, either in active name node or backup name node. Yes, those two are different machines. Okay. So here, primary name node and backup name node maintains the same copy of FS image file in each of these machines. But coming to the second component, edit log, this will not be present in neither in primary name node nor in backup name node. This will be present. This will be stored in some NFS network, some NAS system or something, network file system, where you will have high reliability on that file system. It will not go down that easily. So in that file system, they store this edit log. So now you will have the FS image copy present in both the name nodes, primary and backup. And this edit log is present in some NFS, network file system. Okay. So now for every 1 hour, your secondary name node goes to primary name node and brings its FS image file and gets the edit log file present on NFS and prepares the updated FS image file. And this updated FS image file will be copied back to both primary name node and backup name node. So even at 8 p.m., so at 8 p.m. or at 7 p.m., let's assume at 7 p.m., these two are in the same status because they both received the updated FS image file. And now the same scenario happened at 7:55. This active name node gone down. But this time, this edit log is being maintained in a separate file system, which is NFS, network attached file system or something. And you have the last 1 hour back, 1 hour back FS image file, which contains 152 records. And you have this edit log file on NFS, which contains the 10 records. And if you restart this name node by copying this edit log into this location, now during its restart, it merges those 10 also, and it creates the updated file with 162 records during its restart, during that safe mode period. Now you didn't lost any file, and just restarting this with a small edit log file which contains only the 1 hour transactions will not take more than 5 to 10 minutes. So if primary name node goes down, then the backup name node has the latest FS image file updated with this, and now it can serve all the client requests and it can interact with all the data nodes. So even in my terminal that where I have shown you, so our cluster is, you have seen the CDH 2.6, which means Hadoop 2.5 and above. So it is as per the Hadoop 2.0 architecture, right? So in the high availability mode, so we should maintain the backup name node also. So that reason, so the first one is the primary name node and the second one is the backup name node. That's why when I requested for the name nodes names, I got both the name nodes. And when I tried to browse the file system with the backup name node, I was not able to, because backup name node, as of now, it's not active. Only if the primary name node goes down, then only backup name node becomes active. Until then, via that backup name node, you can't access the files. Do both secondary name node and backup name node also require any restart? Backup name node requires restarts. Same like that. And secondary name node doesn't require any restarts. So the reason why I went this much deeper into these components, I mean, believe me, you will never come back to these components again in your actual development period. But the reason is you will come across these keywords most frequently. So name node, and you might come across the secondary name node. You might hear the backup name nodes, those keywords. But you should know the differences between these three. And you can only understand the differences once you know the responsibilities of each of these. Okay. So don't get confused here. I can clarify you once again if you need. But this is not really mandatory for developers. So why do we update cluster ever by restarting? So when we can update using secondary name node file in less time. Yes. So that is why updating cluster means your context might be different. What is your question? So why do we update cluster? Updating cluster means Hadoop versions.
Hi Shiva, Neetu here.
Yeah, Neetu.
Updating cluster, by this question I mean, why do we ever restart the main name node file?
Okay.
And which take 5 to 6 hours versus just shifting.
I got the intent. So if you have secondary name node, you don't your name node restart will not take 5 to 6 hours time, even whenever you restart. Okay. And then your next question is, why do we need to restart at least that time, right?
No, this was just the question that why do we ever need to restart the main machine for updating the logs if we can just copy the file from the secondary name node and update the name node file?
During that time, your restart purpose is not for updating log files with the master. something else.
Sorry, didn't get it.
So your secondary name node gets the FS image file and edit log file from primary name node, and it merges and it puts that back to primary name node.
Yes.
Right? So now, till now, I was telling that during the restart, this happens. Okay.
Yeah.
Right? So during the restart, so that doesn't mean that I will restart only for this purpose. Okay. So whenever I change any configurations in the cluster, for example, in my etc conf folders, I changed something, some property. Let's assume I have some permissions enabled or disabled here. Okay. So some security permissions, the cluster wise. So client read short circuit. This is one of the optimization property. So that will be useful for your Impala, improving your Impala performances. Okay. So let's assume you changed this configuration property. So this property should get reflected in the cluster. So here you need to restart your cluster, right?
Yeah.
So here the purpose is different. So even if you restart in this purpose also, that time also your edit log will get merged with your FS image file. But that may not have more than last 1 hour or less than that transactions.
But in case the purpose, we know that the purpose is only to update the transaction log. In that
Only
case,
to update the transactional log, we never restart name nodes anymore. After secondary name node came into Hadoop architecture, so admins are not doing that.
Okay.
Okay. So this is before secondary name node came into picture, and after secondary name node came into picture, so it solves the purpose. So it reduces the downtime, and also it reduces the workload of your name node by merging them separately and putting that updated status back.
Shiva, sometimes when the server goes down, the name node daemon may not run and we need to restart. This also will be the case, right?
Yep. So whenever, okay, so to list down what all scenarios you will restart your cluster, when you change some configuration, and when something goes down, any of the services or even the name node service goes down because of network issue or something, or Hdfs or Hadoop version upgrades. Or there were some bug fixes or patches. Hadoop software patches installations.
But any of these cases will not be given permission to do, right? As a developer.
Developers will never get permissions to your name node to perform any actions. You will get only to edge node. On that edge node, you can only do the read and file level operations. That's it, not cluster level.
Yeah. Okay.
And whatever I discussed till now, it's very critical for administration.
Yeah.
Okay. You can also omit if you didn't like these concepts for developers.
This is only for debugging purpose or some troubleshooting purpose.
Yes, troubleshooting and better understanding the architecture components.
Yeah.
Okay.
Thank you, Shiva.
Yeah, it's not possible for me to explain the purpose of backup name node without covering its previous drawbacks of name node or secondary name node. So that's why. So I had to explain all this stuff.
True.
Okay. So yeah, I hope I tried my best to make you understand. So all these slides contain the same text. So since name node is the only communication gateway for client users applications to get the actual data resting on the nodes, it is a single point of failure as well. If this machine fails by any chance, then all the files on the HDFS file system would be lost. So to avoid that scenarios, to keep the name node resilient to failure, one of the methods for this is maintaining secondary name node. So the secondary name nodes we'll see in the next slide. So here you will get the justification for all these names. I will make these names more justified now. So name node means it contains only the names of all the files, right? I mean, when I say only the names, also the block IDs, that stuff. So since it contains the names of all the files, it was given this name node. And coming to data nodes, for all those files, these slave machines contains the actual data. So that's why they were named as data nodes. And so later you can, so once we already have primary name node, they have named it as a secondary, but it doesn't act like a backup. So that's why they used it as a secondary. But here it acts like a backup also. So they have named it as a backup name. Okay. So now slave machines, data nodes are the slave machines which stores the actual data of your HDFS files. And each data node on a cluster periodically sends a heartbeat message to the name node. So for every 10 seconds, they keep sending the heartbeat messages to the name node. And if your name node doesn't receive a heartbeat message from a particular data node for last 10 minutes, so the maximum time limit that name node waits for a data node is 10 minutes. If it doesn't receive any message for the last 10 minutes, then it will mark that data node as dead data node. And if that is the case, it identifies, it reports that in the name node health, HDFS health summary. So how many dead data nodes are there, decommissioned or dead data nodes are there. So here you will see those dead data nodes, dead nodes. How many are dead? How many are decommissioning nodes means you are stopping those services which are running, which are currently decommissioning. Okay, which are already decommissioned, the above ones are. So how many dead nodes are there? Here it will notify you and what are those dead nodes, and admins can investigate on them further. Okay. So today's session is mostly related to the architecture component and more useful for the administrators. But having an idea on these things will not harm you. Okay. Okay. So data node health may cause the replication factor of some of the blocks to fall below the specified values. So if one data node goes down means, so some of the blocks are lost. That means, so few blocks got under-replicated. So earlier those blocks were 3 copies. Now at least if you take one copy is lost. So for a certain amount of blocks, you have only 2 copies, under-replicated blocks. So for them, those blocks must be re-replicated to bring them back to the replication factor 3. So then those blocks will get again copied onto some other healthy data nodes. So thus all the blocks on a dead data node are re-replicated on other live data nodes and replication factor comes back to normal. So this happens when a data node is failed. Okay. And secondary name node, So I will take metadata every 1 hour and will make it secure. This not a standby for name node. By default connects to name node every hour. Housekeeping backup of name node metadata. So saved metadata is used to bring up the primary name node in case of its failure. So if this is failed, we copy that FS image file from here and put it in name node. So this is your HDFS 1 architecture. So name node and data nodes. These are for HDFS and for MapReduce, job tracker, and task trackers. And so secondary name node was part of your HDFS 1.x architectures also, but backup name node got introduced only in the Hadoop 2.0 architecture. Okay, so backup name node got introduced only. So that's why. So for every 1 hour, this edit log will get merged into FS image file. So which we call it as checkpointing. That takes place for every 1 hour. So this checkpointing will be done by secondary name node. And coming to 2.0 architecture, so I'm leaving this right side part of it. So I will discuss during our MapReduce or yarn session. On left side, so HDFS will have an active name node and secondary name node will be there anyway. And we'll have one backup name node, or this is also called as journal node. And this edit log will be stored in some shared location, which can be accessed by both active name node and backup name node, and also by secondary name node. Okay, I'm not talking about this right side part for now. And you will have data nodes as a slaves part. So these are the components that you might come across in your Hadoop architectures, 2.0 architecture. So name node, secondary name node, and journal node, and data nodes. So that's why you can see that journal node daemon also in your list. See, you can find journal node, and where is the name node? Name node, secondary name node, and data node, and journal node as well. Okay. So this slide, I think I have already shown you. I have a file with 3 blocks, and each with I need to store that file into HDFS with replication factor 3. Then, assuming these 4 data nodes, I have so block 1 copied onto D2, D3, D4, and block 2 copied onto so D2 again, D3, and D1. And block 3 copied onto so D1, D3, and D4. So at max of one copy of a block in one data node. That is one rule that you can easily understand by. So in block replacement algorithm, in block copying algorithm, okay, there is no specific keywords like this, but so at max of one copy of a block will be present in any data node. So 2 copies of the same block will not be present on the same data node. Okay. Now let me introduce you to rack awareness concept also. So here, first before even going to racks, so I will explain you the purpose of rack awareness. Okay. Sometimes you maintain the data centers at different locations, and assume when we have data nodes more than 100. Okay. So generally, these data nodes, when I have 20 data nodes, 10 data nodes, or 30 data nodes, they are not like your physical desktops, right? So they will be nothing but your CPUs, your cabinets that will have cabinets. They look like cabinets. They contain both the processor, CPU, and RAM, and hard disk, and network channels attached to them. So one cabinet. Okay. So generally, how they look like keys. So real data node, how they look like keys. Yes. So generally, they will look like this. So here, so this machine is one processing component, and this above one is one data node, and this is another data node, and this is another data node, this is another data node. So they are piled up into one hardware cabinet. This is called as a rack. So max of 40 data nodes, generally the industry standard. So they maintain 40 data nodes, max of 40 data nodes in case. So some people might divide 5 data nodes into one rack or 10 data nodes into one rack. So max of 40 data nodes into one rack. Okay. So in that case, either if you have 100 data nodes or 120 data nodes, then you should split that into 3 racks. So the advantage with these racks, one more advantage is you can put these 3 racks in different places also. So one in New Jersey, one in Tampa, one in Vegas. And you have, you can have connected them through network cables, and all the 3 acts like a combined cluster. So one rack contains the max of 40 data nodes. Let's assume this is one rack, and this is another rack, and this is another rack. Okay, so you have different racks. You have multiple racks. So considering some of the data nodes into them. Now, coming to the block copying algorithm. So you have already got 1 point, 1 rule. So at max of 1 copy of any block will be present in any data node. Taking the racks also into picture, the rule, one more rule is at max 2 copies of any block can be stored in one rack. So that means more than 2 copies storing in one single rack is not allowed. If you have 3 replication factor, max of 2 can be stored in one rack. The third copy should be obviously present in different rack. So that way, if you have one rack in, let's assume one rack in one city and the other rack in another city, if something happened to that entire city, even if you lost that entire rack, then you have at least 1 copy available on the other rack. That is one advantage with the racks. Okay. And so now you have, that is one advantage. So one rack present in New Jersey, and one rack present in Hyderabad. So they have connected their cluster through network, and so you have your request coming from your client is from Hyderabad, and he wants to read a particular file, and for that file the block one copy is present in Hyderabad and two copies are present in Jersey. Then your name node will give the address of this data node first. Whichever the data node that is present in the Hyderabad data center, that will be given to your client first, based on the distance, network distance. Okay. So based on the network distance between the client and the block in the sorted order, whichever is closer, so that one will be given to the client. So this is called as rack awareness of these racks, which rack is closer, which rack is not closer to the client requests. So finding that information is also called as rack awareness of your name node. Okay, so again, this topic you will never see in your day-to-day Hadoop developer life cycle. Okay. So just for understanding the backend concepts, that's it. So let's assume I have a file.txt file, and this file is having two blocks, block A and block B, and I have three racks here, rack 1, rack 2, and rack 3, each rack with 5 data nodes in there. So this is data node 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. Okay. So now, so my block A, this got copied onto, so one copy into this rack 1, and that copy is present in DN1 at max of 2 copies. It could have stored one copy in this rack 2 and the third copy also into rack 3 as well. That is also possible. Okay. And block B copied one copy into rack 2 and 2 copies into this. Okay, this is just to to be fault tolerant even in case of the entire rack failure. So now let's assume entire this rack 2 failed, but still you can access block A and block B, block A from rack 1 and block B from rack 3, and assume entire rack 1 is failed. So all the 5 data nodes gone down. This is because of this rack itself is down. In that case, you have block A present in rack 2 and block B either from rack 2 or rack 3. Right? And the same case if rack 3 goes down. So in order to survive, even in case of entire rack failures, so they have that second rule, at max of 2 copies in any rack. Okay. So now, so that is the advantage of maintaining into racks. So one is the closest rack will be picked up for serving your requests, and the other one is so it can survive of natural calamities that can happen into any data center. And the other reason is, that's it, I think. Okay, so now coming to the performance or the speed. So let's say you have some task running on this So anytime data transfer between two data nodes that is present within the same rack will be relatively faster than two data nodes between across the racks. Copying block from 1 to 2 will be faster than 1 to 6. Okay, it's obvious, right? So it's within the same network cable, and this is across the rack. So one rack to other rack, copying this, it takes some time. So that's why even we will have some racks present in Tampa and some racks present in Lebanon in our real-time cluster. Okay, so anatomy of file write and file read we have seen yesterday itself. So safe mode, I just gave you one-line introduction there. So during the restart of your name node, it enters into safe mode. Same like your Windows. Sometimes whenever you are restarting your Windows machine, so it might go into safe mode where you can't run any where you can't edit or something. You can. It is used mainly to restore or something like that stuff. But here, so during the safe mode, so it merges that edit log with the fsimage file. So during safe mode, HDFS cluster is read-only, and it will not allow you to create any files or update. Anyway, you can't update files. It will not allow you to delete any files. And since it is a read-only, it doesn't replicate or delete blocks. So it loads the file system namespace, which is fsimage, the last saved fsimage into its main memory, and the edit logs, merges edit logs into fsimage, and then it receives the block reports. So during this time, during this 30 minutes window or sometime, all the data nodes send the name node about the blocks that those data nodes are storing. Data node 1 sends Mr. Name node, I am storing these block IDs with me. So and data node 2 sends Mr. Name node, I am storing these block IDs with me. So during that safe mode period, all the data nodes send their block IDs information to the name node. Updated, I mean, it just gets the latest status. Name node enters safe mode automatically during its startup. Okay, and after startup of your name node, it automatically comes out of that name node in another 10-15 minutes or sometimes 20 minutes, 30 minutes. So you don't need to do anything for that. It comes out of that safe mode automatically.
Shiva, sorry to interrupt.
Yeah.
Just a small question. So during this restart or whatever, the entire HDFS, all the file system is available read-only mode?
Yes,
or
read-only mode.
You mean like I can still access and look for any data and anything you mean?
Yes.
And how about doing any, pulling any reports from that or something? Can I do that too?
Reading is possible. Creating a report means you will not have rights. If it is reading, just reading, it's possible. So that's why most probably if they want to do any restarts, they will do during the weekends, midnights, so that it will not impact many users.
Okay, but why not reading reports? I'm just curious because
reading reports is fine.
Yeah, well, I mean, like it's not writing, right? If you are trying to generate any reports,
as long as it is not writing, it's fine.
As long, okay.
Yep.
So you can generate any reports, and your other like Hive and others will still work. So you can use Hive to access the HDFS and run some.
See, this is a relatively small amount of time. You don't need to consider that much for that.
Okay.
So this is not 1 day downtime, right? This is just 15 minutes or 30 minutes. And that too during the weekends and midnights. You really don't need to consider all those scenarios. You don't even need to think of those scenarios. So that is my intent.
Yeah, and just to understand, I think I'm just going forward, but when you are restarting this name node, as a resource manager or GAN also restart along with it, or
no. So
they can be done independently.
They can be done independently, yes. So if your name node is restarted, only the name node service gets restarted. If you want to restart your data node daemons on all the machines, again you can specify that separately.
Okay. I'm just trying to get through this.
That is purely for admins. Okay, you don't need.
Because when you said we restart it usually for putting patches and stuff.
Yep.
So I'm assuming like a patch from anyone would usually involve all the landscape, not just part of that content. So I'm wondering if these both can run independently, or are there any dependencies between the name node and yarn and all that stuff?
Obviously, if name node goes down, your yarn will not work first thing. See, if you can't, if name node is down, if it is in safe mode during its restart, that's fine. If it is completely stopped, that means you can't access your HDFS. Without accessing the file system, what can your yarn can do?
Okay. Thanks.
Okay. Yep. So this HDFS rebalance, this is again, so you guys were asking like that. So how does it actually distributes the workload between all the data nodes? So whenever some data node goes down, so there will be some under-replicated blocks, or when a new data node is added to the cluster. So this topic is again purely for administrators. So if they observe the uneven nature of the workload of your storage capacity on the data nodes, so where you have seen the data nodes capacity here, right? When I was showing you here. I think I was showing you. So they observe that. So here they will observe. So how much it is utilized. On an average, they all are equal or not. So you can see on an average, they are almost close to 17 terabytes. So that means it's in balanced state, except one or two machine, maybe one machine. It's just 86% or utilized. Yeah, it's percentage utilization. So its total capacity itself is 15 terabytes, 15.8. So that's why we stored only 13. So percentage utilization wise, if you see, all are around 85, 86, 87. So how does they achieve this? If they all of a sudden, if they add a new data node to this list, that will be empty. And how will you copy your blocks into that? By running the HDFS rebalancer command. So that is the command that the admins will run. Okay, even this will be accessed only by the administrators. So if a rebalancer is triggered, name node will scan entire data node list. When underutilized data node is found, it moves blocks from overutilized data nodes to this current data. And if overutilized data node is found, it moves blocks from this data node to underutilized ones. Okay, so till now, whatever we discussed, it's just purely related to your architecture, how does your Hadoop works, and mostly important for your administrators. So from now onwards, whatever we are going to discuss, it's more important for developers.
Shiva, quick question, Shiva.
Yep, I want to give a pass here and poll for any questions. So far, yes, Anand. Okay.
Is there a separate admin architecture class?
Admin architecture class, I don't have separately. It's the same. So you want me to separate them out? Getting confused?
No, this is actually very helpful. No, this is really good.
Okay. Yeah, some people might not show interest, but see, even if you don't want to be admin, just listen it for once. Just at least you will store those keywords in mind. So from today's from now onwards, whatever I cover is more needed for developers. Okay.
Actually, it was the other way. I wanted more of admin stuff as well. So.
Oh, okay.
Thank you.
Okay. Okay. So any more questions, or did I make you confused with those architectural concepts, or you guys clear? Okay, thanks, Lakshman. So I have a question from Anand. Can we merge FS image file between Hadoop clusters? Merging FS image file between clusters is not will not make sense, because even if you merge the metadata, you will not find the data there, and that will be altogether some junk. It will become like a junk. So it will have some different data node names. Okay, so that will not work out. And I have a question from Neetu. If due to dead node, replication location change, so will update location be reflected in web file system? In web HDFS UI, Neetu? If that's the case, yes. You will see that updated location there in the web HDFS UI. Also, it gets updated with the name node as well. Okay. Okay. Yeah, thanks. Thanks, guys. So let's move on to the actual development, the file system commands that's needed for the developers. So for making this session understanding, these commands understanding, I took the Linux session for you guys, the Linux commands. Okay. So since so if anybody is interested in exploring where does this actual FS image file and edit file get stored, even that I can show you guys. Maybe if you guys interested sometime later, but not now. But if I put that aside, since this HDFS is built from the Linux file systems, so we see the same kind of commands, similar kind of commands and similar kind of file paths and directories, everything there. Okay. So the basic command that you should know to list your Hadoop files. So in your Hadoop space FS for file system, minus ls for listing, and provide the path. And this will list down the directories that are present in your root folder. Okay, same as your Linux file system. So slash is the root folder, and under that you will have the parent directories. And any application level informations you will find here. So your HBase related data will get stored in this, and your Solar is another tool. That tool's information data will be stored in this, and all the logs, any logs will get stored in var/var, and temp data will be present in /temp, and this is some directory I have created. Okay, so with Hive user. So this all the users related data will be present in this user. So if you have 100 users, all the 100 users data will be present in this user directory. So if I want to list in that, so -ls /user. Okay, so I have Cloudera user, I have history user, I have Hive user, I have Oozie user, I have Spark user. And if I go to Cloudera user, Hadoop fs -ls /user /Cloudera. Okay, so these commands are very simple, self-explanatory. If you understand the Linux command syntax, that's it. So in my home directory, /user /Cloudera, so I have these many files. So for directories, you don't see the replication here. The replication will not be at directory level, it will be at file levels. So files get replicated, not the directories. Okay, so in your pseudo clusters, you will always see, so replication factor is 1 only, because you have that set up in your hdfs site.xml file, dfs.rpg as 1. Same like in Linux, if you want to see these sizes in human readable format, so -h option, yes, that is available even in Hadoop. Hadoop fs -ls -h, I think. So Control-Shift-C is for copying, and Control-Shift-V is for pasting. So -h will display that sizes in the form of kilobytes, MBs, and that. Okay, and if you want to see the recursive list of these data, recursive subdirectories files also, and you can use -r for recursive. -r, -h. Capital R, it should be capital R. See, it's all the recursive listing of. In each subdirectory, whatever the files are there, you can see all of them. It's in data, inside data this directory, and inside this directory key equal to 1 is another directory, and inside that this is the file. It browses you till the low level until reach the files. Okay, so that is ls command. So that's the first command you should learn. Next, how to create a directory. Same as your Unix make directory command.
Siva, small question.
Yes.
Hasita here. Like, can we access the HDFS and the metastore of Hive like through web interface? Like you have shown how you can see the users and all using command shell, right?
Mm-hmm.
So, where exactly do you go and access them through web interface?
Which one? Is FS metadata file?
Yep, the HDFS files. Like whatever the file structure that we have seen, will it be visible through the Cloudera web interface?
Yes, you are seeing them, right? The files you are able to see here in the browse file system, right? But not the data of them.
Okay, no, I was just trying that in my Cloudera version, but I couldn't see that. So
okay, so here this is under root. I have these folders, and in the terminal, I have seen the same system.
yes, yeah,
Right? and in my under root I have HBase POC solar temp. Same thing you can access here. And inside user I have Cloudera, and inside Cloudera you can see the same files that are I'm able to run them here.
Yes. Yeah. Okay.
Okay. Does that answers your question, or you something else?
Yeah, it does. Like, I think it's different with mine. I have to like figure out where exactly it is.
Oh, okay. Okay. No issues. Okay. So that is listing down. Now, and one more point that I should highlight is your web HDFS UI is just read only. This is read only. You can't create directories here. You can't upload files here through browser, through web browser. You can only do that through command line. Okay, so that is the difference between command line mode of accessing the files and web browser mode of accessing the files. Okay. So I think, so let me continue. Shall I continue with the commands, or? So I received some questions. Yes, show whenever you get time. Shiva, can you please outline what tasks developer will undertake? Any scenarios would be great. Outlining those things at this point of time may not be that much clear, Anand. Yes, sometime later. Okay. So can you please tell me again rack and its importance? I will tell you in the offline, Soumya. Okay, don't worry. You are the only one, right? Okay, let me continue with the commands. So that is for listing down. ls is for -ls is for listing down the files and directories. So now, in case if you want to create a directory, okay, so Hadoop fs-mkdir/user and /Cloudera, so /test/ my file one. Okay, files. So this directory I want to create. So first, it should not. Let me see whether it will create or not. So it's not creating for me. So the reason is its parent directory test is not present. So for that, either I should create the parent directory first, this way. I know that /user/Cloudera directory is present. So test directory is not there. So now I create it. So it got created. And if I create files subdirectory under test, it will get created. Okay, now it got created. It didn't throw me any error message. On the other hand, we have one option to do. Any missing parent directories will also get created. So now I don't have test1, I don't have files1 directories. If I create this, even the parent directory test1 will get created. Under that, files1 subdirectory will get created if I provide the -p option. So it creates the parent directories as well. Okay, so now if I list down ls -r. Okay, so it listed both test_files, test/files, and test1/files. Right? So that is bit about make directory. Similar to your Linux make directory only. But you, instead of just make directory, you will have Hadoop fs-make directory. That's it. And ls we have seen. So -h option, -r option also we have seen. So -d parent directories are listed as plain files. If you put that -d option also. I will leave remaining things for your exploring. Okay. So regular expression also you can give. That star I have given, it gave me the test and as well as test one. And the result of your ls command will display this way. The permissions for directories hyphen you have seen here, right? So for directories it is hyphen. If it is a file, it displays the replication factor of that file. So since Hive is a directory, since users is a directory here, so it displayed the hyphen here and a D for the first character, denoting it's a directory. Here for regular files, the first character is hyphen, the second flag denotes the replication factor of that. And remaining stuff is user, group, file size, last modified date and time. Okay, so that is make directory and listing. Now you have created a directory. Now if you want to write a file there, if you want to create a file, just now I created a directory, but I want to create a file there. So for creating file on the HDFS itself through the command line, I have one command like append to file. So from source, if I give hyphen as source and t1.txt.
Oh, Shiva?
Yeah, Hasita.
Akila here.
Akila. Okay.
How can we do inter-cluster copying, right, and operations like from one cluster to other
One cluster to another cluster? Yes, that I have in my slides, Akila. I will cover that.
Okay. As you were saying this, no, so I got that out. Like it is only between one data node, right?
Yes.
It is between
one cluster, not
one cluster. Sorry.
Yep, it's in one
cluster.
Yep.
Yeah.
This is test file. So I'm directly creating a file on HDFS.
Yeah.
Okay. So now I created this file. Let me list whether this file is present there or not. Okay, so this file is there. This is a file and it's just of 24 bytes. And to view the contents of any HDFS file, the same way in your Linux you have cat command, right? So same way here you have the cat command. So you can display the contents of it. So hello HDFS, this is a test. So these are the two lines that I have written to my HDFS file directly. So
Shiva, if we are in the same directory, we need not to give the path every time for every command, right?
I didn't get your question, Nakla. I mean, what is
like if we do cd user Cloudera, we need not to give all the time the same path for every command.
In local file system, that is possible. In Hadoop, there is no cd command.
Okay, in Hadoop cd command is not possible.
File system, cd command is not there.
Okay.
So you can't change your control into that particular directory. Okay. So yeah, so that is one difference that you can observe between your local file system and HDFS. So now, sometimes people got confused with these paths. So this is the HDFS path, but not your local file system path. Sometimes, like they wanted to see these files from the browser, and they were looking for the / which is file system, right? And under this, they were looking for USER directory. You will not be able to find these directories in your local file system. So your local file system, something which is your local to your Linux machine. So whatever you see the directories with Hadoop fs minus ls, they are your HDFS directories. Those directories can be browsable or viewable through your file browsers. You can't find them here. Okay. And you can't see those files and their data. Okay. Because yeah, some people tried looking there and they complained that so it's not storing anywhere. I'm confused where it stores. Okay. It gets stores in the HDFS. For now, I will leave there. Okay. So let me pick that up later. So once you slowly understand the basics. So this is to view the contents of any HDFS file. Next. So that is one way of creating a file there. The other way is if you have a file that is present in your local file system, on your Linux file system. Let's assume I have a file here. So that is bigdata.txt file. Okay, my home directory. So I want to copy that file. So Hadoop fs hyphen, there is a put command. Put that file into HDFS.
Shiva, can you create a file in HDFS without creating an LFS?
Yes, that's how I created, right?
Okay.
File I created directly in the HDFS.
Okay, then how will we write it? Whatever the data we need to write.
Here I have written right in the terminal itself.
Okay.
So here, so append to file. So append to file command takes arguments. The first argument, it could be either from your LFS file. Hyphen means it reads it from the console.
Okay. Thank you.
So here, if you give the LFS file path, that file contents will get copied onto your HDFS file contents. If you give just the hyphen, your console will become the input. Whatever you type on the console will become the input for your HDFS file.
Okay. Usually I was doing the other way. I was creating in the LFS and using this put command. I was.
Yeah, that is another option. But this append to file got introduced in the recent releases of Hadoop. So in the older versions of Hadoop, you will not find that command. So from Hadoop 2.3 or 2.4 onwards, it came into existence. Okay. So yeah, so other way is, so now I have that bigdata.txt file in my local file system, in my here, this home directory. If I want to upload this into HDFS, yes. So if you already have the same file and your local file got changed, so some contents you have changed. In the local file, you removed one line, but in your HDFS, that line is not removed. If you want to upload this again, one way is either you remove that file present in your HDFS and re-upload it, or simply upload it with -f option. -f means force upload. It overwrites. If you don't use -f, it throws you error message that the file already exists there. So file exists. To overcome this, either you should use, first you should remove. For removal, we have rm command. Oh, it's an invalid syntax. So try to look for that file. Bigdata.txt file. So it removes that. Okay, so it deleted this. And same like in your Linux file system. So in your Linux, you have trash, right? So if you remove anything, so if you move to, it will go to trash, right? And same as in your Linux, in your HDFS, if you remove anything, it goes to trash. So there will be some trash directory configured separately for each cluster by the administrators. In case by mistake, if you delete any HDFS file, and if they have enabled the trash policy on the cluster, and if you ask your administrator what is the trash directory path, they will give you the directory, and from there you can access your file back. But here this means deletion interval is 0 minutes, emptier interval is 0 minutes, means there is no trash enabled. It directly deletes the files. Okay. So now I remove this file, and if I put this, it will get uploaded. So if I removed one more line in the local file system and want to, so the other way of uploading is just to use the overwrite. -put -f will overwrite the existing file there. Okay, so that's about put, and I will leave preserves the access and modification times -p. So I will leave that you to explore that. So similarly, if you have a file and the same put command, instead of put command, you can use copy from local as well, which acts like same like put command, -copy from local. And same way you have get command, where you can get your HDFS file into your local file system. Get, so big data.txt into /user/cloudera/ in the home directory. I already have that. Let me create some test. Into test. This is my local directory. It brings that big data.txt file. No such file or directory. Sorry. So in my local file system, /user is not /home. My home directory path is /home/cloudera. Okay. So now if I look in this directory, I can see this big data.txt with those 2 lines removed, which is my latest HDFS file. Same as this one.
I have one question.
Yes.
When we get the file into HDFS system, does that mean we are getting the file in name node?
No, name node only stores the names. The data name node stores the name of that file, and the actual data contents of that file will be present in data nodes.
Okay, so when we create any file in HDFS, so that means now name node has started storing the information about the file?
Yes, metadata about that file, name node stores that, and data for that file gets stored by data nodes.
Okay, so the file, the 2-line file that you just created, so now the name node must be getting information about that file.
Obviously, yep.
Okay. Okay, thank you.
Yep. So where does this file name get stored in the name node? In the FS image. So currently not into FS image file. It will be present into your edit log file.
So,
Maybe in another 1 hour, so this edit log records get merged into FS image, and this file name and all its permissions, this entire line. So all this information will get loaded into FS image file.
so even the files that we deleted, that will also get uploaded.
That entry will also be, that record entry will also be present in edit log. Yes.
Okay.
Okay. Yep.
Thank you.
Yep. Thanks. So yeah. So get command cat we have seen. Similarly, from one HDFS directory to another HDFS directory, same as your Linux CP command, we have CP for copying file from one HDFS directory to another. Okay. So I want you to try these things. Move command MV. For remove, I have shown you for if trash is enabled on your cluster, but still you don't want that deleted file to go into trash, you can specify this -skip trash. This is like shift delete. Okay. And if it is a directory and you want to remove that directory and as well as its files present in that directory, you can use -R to recursively delete the directories. Okay, so I want you to give them a try. And get merge, actually it takes a directory, HDFS directory as input parameter, and your local directory as a local directory and file name as output parameter. All the files that are present in one HDFS directory will get merged into one single file, and that single file content will be present in one text file in your local file system. So why do we need this command? So you will understand during our MapReduce. Maybe that time if I show you this, that may make sense more. And replication factor. So you have seen that property dfs.replication property, which can be set at cluster level. Okay, I have set this property in hdfs site.xml file. Means if you have 100 files on your cluster, for all the 100 files, it's the same replication factor. But out of them, you have created one special file where you want replication factor to be 2 or 3. Then you can change for that particular file alone. So how can you do that is, so Hadoop fs -setrep -R, if it is a directory or something, -R and number and file path. So let me set replication for 1. Obviously it will not get replicated twice because I have only one data node.
Replication is not possible for a directory, no? Then why are we using -R, Shiva?
-R just to specify. -R here, that is not for recursive, for telling the replication number.
Okay, okay.
So set rep with data.txt -R2 oh, this is home. Okay, this is local file system. So /user/cloudera/test/files/bigdata.txt. So replication 2 set to this file. But if you check ls of this file, it will show as a 2 only. But let's see. Okay, so replication factor set to 2. Now let's browse through that file /user/cloudera. Test is our directory, right? And files, and replication factor is 2. And you can see here that block 0 should be copied onto 2 data nodes, but you can see only 1. The reason is, this is my pseudo cluster and I have only 1 data node. This is an example for under replicated block. So we requested for 2 replication factor on this file, but I have only 1 copy here. And if you go and refresh this file system, it should point to under replicated blocks. How many? See, number of under replicated blocks. Now it's reporting as 1. So till now, when I showed you last time, it was 0. Correct?
Sure.
Yes, Anand.
Why would we set the replication factor here? Because I thought we already set that on the client. Initially
Cluster side, right?
Right.
When you already set up at cluster level, why do you need to set the replication factor at file level? Correct?
Correct.
Okay. So you have set up your cluster levels replication factor as 3. Okay. For all the files on the cluster. There is some financial file, there is some confidential file, some encrypted file, but which is very important. And you don't want to lose that file at any cost. Okay. So if you have 3 copies, if all of a sudden if 2 racks goes down and all the 3 copies are present in those 2 copies only, and 2 racks only, then you lost that file, right? So to avoid such, if you keep the more replication factor, the more safety you can get on that file. So that is such a critical file, and if you want to have more replicated on that file, so then you can control that replication at file level. That for that confidential financial file, I can make the replication factor as 5. It gets copied onto 5 data nodes then, each block.
Okay, perfect, got it.
Okay, yeah.
Thank you.
Okay, so you can touch Z. I will, same as your Unix touch Z command, it changes the timestamp, modified timestamp. So here you can see, here you can see a file, so which was modified at 8:31. And if I touch base, if I touch this, touch Z, will actually create an empty file, or touch Z. Let me see what will happen with the existing file. Not a 0 length file. Okay. So it creates actually a 0 length file. Okay, with that particular timestamp. Same like your Unix touch Z command. So if you list files in this directory, you can see one created with an empty file. So it's like creating an empty file there. It's a bigdata1.txt created at, so this 844 and with 0 bytes, 0 length. Okay, so that is a way of creating an empty file. And in your HDFS, if you want to, if you received a path as a parameter, and if you want to check whether it's a directory or not. So then you can have test command -test -d followed by the path. It tells you whether it's a test directory or not. And if the file exists or not, if that directory exists or not, you can use -e. If it is a file or not, you can specify with option -f. If it is having more than 0 size, -s. If the 0 size, -z. Let me show that one example. Okay, so test -z bigdata1.txt. That is a 0 length file, right? Bigdata1.txt. It actually does not. It will not show any response here, but yeah, you should capture the written code of these. Okay, so this is like a capturing its status into one variable. It returns a. You can't observe that result there. So return 0 if path is directory. Returns 0 if path exists. So you can assign this in shell scripts. This command might be useful, not on the terminal. Okay. Expunge is used to empty your trash. And append to file we have already seen. Tail, same as your Unix style. View the last 1 KB of the file. DF, disk free, how much disk space that is free. DU, how much disk you utilized. And count and give the path. It gives the count of the directories and files of those things. Okay, so there are total of 3 files. Okay. And if you want to see disk utilized, -h, it displays you. Okay, so change group, change mode. Changing the permissions of your HDFS files, same as your ch mode that I have shown in Linux LFS, local file system. It's the same. It's exactly same. Okay, so this distributed file copy. So copying from one environment to another environment, I will take up tomorrow. I already exceeded your time. It took 20 minutes more from you. So, I mean, I wanted to cover all the commands in one go. And from today's session, for developers, you need to concentrate more on the last 50 minutes that we discussed on the file system commands, the last 40 minutes. So from understanding the architecture point of view and gaining the admin knowledge as well, you can revisit all other topics as well. Okay, and after completing tomorrow's session, I will be giving you assignments on HDFS, and you will get 3 days break. I want all of you to submit the answers for those assignments. Okay, any questions? Is it clear?
Shiva, I know you will answer that later. But what a developer can do, like it's only loading the data, right?
It's a broader scope question, Anand. I will take it up sometime later. Okay, no worries.
Okay. Okay.
I will explain, definitely explain this. So roles and responsibilities of developer, architect, and admin, I sometime remind me sometime later. I will explain in the session itself. Okay, daily and day-to-day roles and responsibilities. Any other questions related to the topics that we discussed? Okay, if not, yeah, thank you everyone. Bye-bye.